He's like, he's like, oh my gosh, he failed in class, and he gets like,
Wow, it's still not going.
this whole thing, and he's, it kind of looks like he's trying to hypnotize you, but it's no, that's not his part. That's Tinker's part.
Well, that's just gonna be like that.
Sleepover. Play date. Yes. That's we should have a. You're not gonna have five.
All right, I give up. It doesn't want to play. I don't know why it doesn't want to play, but it doesn't want to play.
Yeah, go fill the people who are.
It's not letting us. It's not letting me.
Fill everyone on virtual.
I can try one more thing here. Oh, wait a minute. One more thing. Well, the people who are virtual are lucky because they get to see what's on my screen anyway. I was just wondering, you guys. Oh, wait, here it goes. Now it's going to play. Only took it a year and a half. We got it. Woo. Okay.
If it's actually a half,
Of course, I'm saying that I don't see my image yet. So fingers crossed. Hello, people. All right. So sorry. I don't like to start late, but that was a nightmare right there. All right. I'm going to pass these back. Drew, Lily, Alec, Ella. We'll send slide together or whatever. Drew, Alec, Ella, Eleanor, and Jules. Got it. All right. So today we are doing, got on my page back here, right? There we are. All right. Now we have all my people. Look at this. I love it. All right. So now that we're all here, hi, people.
Hello.
See everybody up there.
I
So
am.
we're gonna do, my camera's not on. There we go. So today we are starting our concentration and solubility. And for those of you who aren't here, we actually have, I'm gonna do a little demo today during lab, and I'm gonna record it. And I'll post it so you guys know where to go see it, because it should be kind of fun. If it all works out well, it'll be super cool. So I'm going to share my screen so you can see what I've got here. There we are. So, there. Nope, there. Nope, there. So concentration and solubility. So we're starting into acids, bases, and solutions. This means we're getting kind of towards the end of our inorganic general chemistry stuff. So once we get through this kind of stuff, we're going to start moving more into our organic chemistry stuff, which is going to lead really nicely into biology. So concentration and solubility, how is concentration changed? Do you guys remember from your reading? By what? I couldn't hear you. You can add or remove, right? Okay, so if you wanted to make something less concentrated, would you add more solute or solvent? Do you remember?
Less solid.
Less concentrated. Would you add less solute? Wait a minute, would you add more solute or more solvent?
More solvent.
Yeah, there you go, more solvent, right? Okay, so that's where we're heading today. So what does solubility mean? So some of your questions from your notes will be answered up here too today. So solubility, anybody want to try and give me some good descriptions? So it's the ability of a solid, liquid, or a gaseous chemical substance, referred to as a solute, to dissolve in a solvent, which is usually a liquid, but not always, and form a solution. Can anybody think of an example of a solid solution? This is a harder one. Solid solution.
What's it called? Resin?
Resin. That's okay. That's a good one. That's a solution. Is it a solution? It's made solid. But
because it feels like a solid, but a liquid.
That's a weird thing, isn't it? It's like a phase thing. So what I'm thinking of is
It's just food color.
food coloring. Oh, food coloring. Okay, so that's a solution. And then it's then frozen. Okay, that's what they're getting at. Yeah. But you can also do things like we'll talk about alloys and things like brass later. That's pretty
Iron
interesting.
Man suit. I know it.
Iron Man suit. Okay.
Go to Titanium Valley.
There you go. And then there's also can anybody think of a very common gaseous solution?
gaseous.
What's around us?
Oh, air.
There you go. And sometimes gas gets dissolved in a liquid, like in a soda, right? So solubility is the measure of how much solute can be dissolved in a solvent. So if you look, here's a graphic for you up there for you guys that are here. So we have solution, and then we have a suspension where you've got the little particles, right? We talked about suspensions, what, last week, I think? And then the stuff that falls to the bottom when you have a suspension is called the precipitate, right? We know that. And the stuff that doesn't fall, you see that? That's the supernatant. So concentration. What's concentration mean?
Means to concentrate.
Means to concentrate on something. There's a one way around it. What else does it mean?
Concentrated mixture.
Yeah. So it's the amount of a substance, and you define that by space or volume, or the ratio of the solute in a solution to either the solvent or the total solution. So here's where concentration and another term we use in chemistry get a little, this is where they're different and where they matter. Okay, so you can define the concentration as, say you have 100 milliliters of liquid solution in a beaker, okay? And some of that is water and some of that is sodium chloride. So now what you have to decide is, are you going to define your solution as 20 grams of sodium chloride in however much water you used, or is it 20 grams of sodium chloride in that whole 100 milliliters? And with a solid like that, it's not as obvious, but say you had two liquids that you put into solution together. So say you have, liquid A and liquid, all right? And liquid A is your solute, liquid B is your solvent. You put them in together, all right? Picturing this, guys? Put them in together. You had 30 milliliters of one and 70 milliliters of the other. So now you have 100 milliliters of solution. Do you describe it as 30 milliliters of solute dissolved in a 100 milliliter solution, or you describe it as 30 milliliters of solute dissolved in 70 milliliters of solvent? You see how you can do it both ways? So what we end up doing in chemistry often is we'll use a term called molarity, and that is a little specific because it has to do with how much is dissolved within a predetermined volume. The volume is always predetermined. And you'll see it in a couple weeks, specifically when we start doing, we're gonna start doing some titrations. And when we do that, the bottles will bring out, we'll say like 0.25 M, and that M means molar. So it's molarity of the solution. That's a more specific way to define something. And so also your concentration of a solution is the quantity of a solute contained in a particular quantity of solvent or solution, right? Two different ways to say the same thing. Okay, now look up there. Which one of those do you think is most concentrated? If you had to guess.
Dark red.
Yeah, I would guess that. Probably. Whatever they've dissolved in there, there's probably more of it there in that dark red one. If this was Kool-Aid, which one would be the tastiest? Probably.
Tastiest number two.
Yeah, which one would be yummy? Would you want to?
dark one?
Yeah, I would go with.
It's not horrible, but like you could just not want much sugar, not want much.
Right. So what happens if you put too much solute in a solvent?
Then it turns into gross.
Wouldn't call that, you remember? Call it saturation or dilution. So here's your dilute solution.
Call it Coke 2.
There you go, Coke 2. So your dilute solution is one that contains only a small amount of the solute in a solvent. Have you ever had anybody make like a lemonade from powder and it barely tastes like anything because there's powder in it and you're like, what's this?
I have to use the small little packets that are like.
Yeah, they're pre-measured so you don't screw it up, right?
We usually we taste test it before we go out and selling it. We pour a small cup. We taste test it and we're like,
Am I the
we're
only one
gonna
who
use
actually
another
made
packet.
lemonade?
You don't like lemonade at all?
No, I made my.
Oh, make your own lemonade from lemons? Oh no, we'll do that
It's
too.
way better.
I agree. We do that too when we can. Yeah.
You can always change the ratio.
Exactly.
Okay,
Ratio.
And Costco lemons are actually good because they are high quality food.
Oh yeah, Costco lemons. So when I'm doing a big event though, like when I do our dance, which I don't know if we're gonna do it this spring or not, I'm kind of waiting another month or two to make a decision. Couldn't do it last year, which was a real bummer. But I use the powdered stuff because there's, 100 people I have to. I'm not-
like ridiculously expensive.
I don't have that much time or money. Yeah. Okay. So you have a dilute solution where there's only a little solute in solvent, and then you have a concentrated solution, and that's the opposite. And that's when you have a lot of solute in a solvent. So you can change the concentration of a solution by adding more solute or by removing what we said earlier. Now, it's usually easier to add more than to take away. And this is what happens, especially when you're cooking. Especially remember this, when you're cooking, if it says to salt your food to taste, sometimes recipes will say that salt to taste, right? That means you put in a little and then you taste it. And if it's not enough, you put a little more, because the last thing you want to do is like dump a lot of salt in it and then you can't take it out, right?
No one people actually mess with the salt.
Yeah.
It's like about
A
1/8
pinch.
teaspoon.
Mm-hmm. Speaking of Costco, so I had one of those big sea salt grinders from Costco one time, and I was making this spinach artichoke cheese dip to take to a party, and it looked so good. I'd been stirring it up, and it was all gooey, and I was like, oh yeah, I had a big bag of chips to go with me, right? And last thing to do was to salt it, and I went to salt it, and the cap broke, and all of the sea salt poured into it. It was like a nightmare, right? It's terrible.
So we were at this restaurant and he had like a boiled egg for something.
Oh no.
And he wanted some salt, so he got a plate. Yeah.
It just poured out. So yeah, there it goes. So I ended up trying to scoop it off, and it didn't. It was too late.
all onto his eggs. So
In some fancier restaurants, I think the waiters actually, like, in front of you, like, they grate cheese.
Yeah.
Like Parmesan.
They'll crack the salt and
They
pepper.
salt it, you, like, tell them.
Yeah. So to dilute a solution, what do? We can add more solvent. And if we're going to concentrate a solution, we can add more solute or remove some solvent. Now, there's a way to remove solvent that I just showed. Just showed you right there. Which one of those do you suppose is remove some solvent? There you go, Ella. Yeah, you heat that up. What's going to happen? If it's water, what's going to happen? It's going to evaporate, right? So as you turn that water into water vapor, you're going to decrease the volume of liquid solvent. So one way to remove some solvent is to heat it up. Now, if you've ever made rock candy, you know that if you heat it up, you can get more solute in, right? That's one of the things that allows you that will increase the solubility of your solute. And in today's lab, the demo I'm going to show you, that's what I did. I made a super saturated solution. And super saturated means that at normal temperature, it has more solute in it than it should be able to hold. But the way heat it up a lot, and it'll take in more and more and more and more, and then it gets to a point where it'll come back to room temperature, and it has more in it than it should. And we're going to do something really cool with it. I tested it last night. It actually works. So I was very excited. All right. So what factors affect solubility? So this is what we're talking about. Pressure, temperature, solvent, and surface area. Surface area, I don't believe was mentioned in your book, but surface area is important. Look at the sugar cubes here. You see the sugar cubes? Okay, imagine you have a sugar cube that's really nicely compacted, a nice hard sugar cube, really compacted one. And then you have a spoonful of sugar. Which is going to dissolve faster? The spoonful, yeah, because what have you done? You've increased the surface area. You've taken all those little granules, crystals of sugar, and you've spread them out, and now the solute can get to more of the surface area of the solvent, and solvent can get to more of the surface area of the solute and dissolve it faster. So if you've ever had have you ever had the, what's the word I want? Candy cane, couldn't think of the word, candy cane, and you put it in your hot chocolate. You ever done that? It takes a while. Eventually it dissolves. Right, but if you were to put sugar in it, it would dissolve really fast in that hot chocolate, right? In the hot cocoa.
And it's like, has a wooden spoon, and on the end, there's like a block of chocolate.
Yeah.
It's so good.
Do you know they do that at Dutch Monkey? You ever had hot chocolate at Dutch Monkey?
No.
So they steam, what they do at okay, so Jocelyn, Dutch Monkey is this donut joint around here. And it's this little family owned place, and their specialty is called the Dutch Monkey. And it's kind of like a Boston cream, but it has sliced bananas on top too. It's very good. But anyway, when they give you hot chocolate, you should try it sometime. They give you a cup of steamed milk and a stick with a giant block of chocolate on the end. And you stir so good. You stir it and stir it and stir it. It's amazing, right?
We never had those ones.
So, oh my goodness.
That was fun.
Oh yeah, this is a great place.
It's good.
So pressure.
I like Dalton chocolate. Oh, I have
Dalton chocolate stick.
what
Yeah,
was-
what's your
what was
question?
this one
Oh,
thing?
sorry.
And like, it was like, what one would make win more? It was kind of like a trick question.
Oh, like feathers or lead or yeah, uh-huh. Mhm.
1 pound of feathers or 1 pound of brick.
Yeah.
And we were like, obviously brick. And my mom was like, no.
1 pound.
They weigh the same.
Yeah, there you go. So pressure, how does pressure affect solubility? Pressure mainly affects solubility where gases are concerned. Not so much with solids or liquids, but mainly where gases are concerned. And this is because of something called Henry's Law. So Henry's Law, I don't think Henry's Law was in here, but Henry's Law says that at a constant temperature, the amount of a given gas that dissolves in a given type and volume of a liquid is directly proportional to the partial pressure of that gas in equilibrium with that liquid. Blah, 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 right? I mean, what did I say? But basically what it's saying is pressure and gas solubility are directly proportional. Do you remember what that means? Directly proportional means if one goes up, the other goes up. If one goes down, the other goes down. So the pressure and the gas solubility are directly proportional. So if you increase the pressure, you increase the solubility. If you decrease the pressure, you decrease the solubility, which makes perfect sense because if you have a soda bottle with the lid on it and you open it, you have now decreased the pressure. And what's the first thing you see?
Bubbles.
Bubbles that are no longer soluble in that liquid that are coming out, right? Perfect. And then we have like our keg over there that Jason was showing the other class. We turn the gas up on that. And then that actually it puts the liquid inside under pressure and it increases the gas solubility and it makes the cider he makes fizzy.
There's like way more bubbles, but in my opinion, soda.
What does? Beer. Oh yeah. Well, so that's what I was just saying. If you want to say something crazy, like our keg right now is like overly pressurized. We have to deal with that because I went to get a cup of cider the other night and I was like, all bubbles all the way up. I got to wait for them to all go down and put a little more in. It takes forever to get like this much cider in the cup because there's so much pressure on it. So temperature.
Have a drinking.
Yeah, temperature and solid solubility. So generally, there's always going to be exceptions to certain things, but generally, the greater the temperature, the greater the solubility. So that means they're what? What kind of proportionality is that? Drew, if there was the greater the temperature, the greater the solubility, what kind of proportionality would that be? Directly or inversely?
Inversely.
No, that would be directly. Right. If one gets greater temperature, greater solubility, that's directly. Right? Yeah. Okay, cool. So they're directly proportional. Now how about gas and temperature solubility? Okay, now this one's interesting. Generally, the greater the temperature, the lower the solubility of the gas. So this means gas and temperature are inversely proportional. And here's why this one is interesting, okay? Keep this in mind when you hear about the relationship between CO2 levels in the atmosphere, in our ecosystem, and the average temperature. So when people talk about climate change or whatever, and they talk about we've had a higher than average temperature for the last so many years, and our CO2 levels have increased. And some people will take the tack, wait a minute, some people take the tack that the CO2 levels have increased because the temperature has increased, or the CO2 levels have caused the temperature to increase because they've increased a greenhouse effect, which makes perfect sense. That's a logical pattern. It can happen. But also, wait a minute, stop. But also, if the temperature of the atmosphere raises, like say there's solar flares or something in general that raises the temperature of the atmosphere, the CO2 that's in the atmosphere is going to be less soluble in the ocean, which means there will naturally be more of it in the atmosphere. So both make sense. So you have to consider both things. You can't consider one without the other. And very often you hear the first and not the second. So if the atmosphere is generally warmer, the ocean is going to absorb less carbon dioxide because it's not as soluble, because they're inversely proportional. All right, so keep an eye on our time. Solvent. Now, like dissolves like. What does that mean?
Well, the same thing dissolves.
Yeah, so here's what we mean by like dissolves like. Polar dissolves polar. And that would be polar molecules or ionic compounds. And then non-polar substances dissolve non-polar substances like non-polar molecules. So you have to remember, like, can you put oil in water? Does one dissolve in the other? No, because they're not like. They're not like and like. You need polar with polar or ionic, which is why polar molecules, as an example, would be sugar, and an ionic compound, an example, would be salt. Water dissolves them both, right? Cool. Oh, and organic. Over here.
Water use it here.
Water, yeah, because water is so common, and it's the universal solvent, right?
Also, you know, like for like, you know, it's comparison, you know.
Mm-hmm.
Like, they
So-
don't go together. It's like oil and water.
Surface area, we talked about surface area. The greater the surface area, the faster something will dissolve, right? So surface area and solid solubility are directly proportional. So saturation. All right, now I've got a great picture there. I love that one. That's a really good, somebody took good art photography in a lab. That's cool. So that's a hot plate, and you're gonna start using those soon too. And that, do you know how it's spinning like that? Do you know what's going on that makes it do that?
A water tornado?
Yeah, but what's making it?
Well, I've actually made one of these. Not like that. But
Yeah, but I'm wondering, what do you think that is? So here's how these work, and we're gonna start using them soon. It's really fun. Underneath this little plate here, yep, is a magnet, and the magnet will spin based on your turning of a dial, how fast you want it to spin. The magnet will spin, and inside of the solution you drop, it looks like a pill, it looks like a big pill, and it's a magnet with polar and non-polar ends. You drop it in and you turn it on, and that is called your magnetic stir, and it will stir your solution for you on the hot plate. So
Slavery by magnets.
yeah. So we have degree of saturation. Would you like somebody to put the blinds down? Are you blinded by the light?
Nah.
You good? Okay.
I've had this.
All right. So degree of saturation. So we have an unsaturated solution. So an unsaturated solution has less than the maximum amount of solute that can be dissolved. So it can continue to dissolve more solid if you put it in. How do you know if your solution can continue to dissolve? What would be a good sign if you're putting solids in?
it just stops.
Yeah, what happens? You get crystals at the bottom. Then, you know, if you're putting sugar in water, you get to a point sooner or later where the crystals won't go away, right? So next week in lab, we're gonna do, we're gonna make a saturated salt solution, not super saturated, but saturated. And the way we'll do that is we'll stir and stir and stir until the salt doesn't dissolve, and then we'll pour it through a filter so that we get only the liquid part, only the solvent and the solute that are dissolved. Okay, then you have saturated solution. So this is where we'll be next week with lab. So that's the maximum amount of solvent that can be dissolved, right? And any more solute, the maximum amount of solvent has been solute. That should say solute. Wow, I copied that from something. Has been dissolved. Any more solute added will sit as crystals on the bottom, which is what we're just saying, Ella. So when you see that, you're like, oh, this is saturated. Super saturated contains more than the maximum amount of solute that is capable of being dissolved at a given temperature. And that's what matters. Because we just talked about when you increase temperature, you increase solubility, right? So if you increase the temperature, you increase the solubility, and you end up with this liquid that is super saturated. It can form crystals, and it can also be unstable. Some of them are so unstable that if you jiggle it, it will instantly start to crystallize, because just the motion is all it needs, and it'll start to crystallize immediately, which is really cool. And last year in physical science, we did something which was called super cooled water. So yeah, you take a bottle of water, it has to be pure, like distilled water. It can't have any impurities in it. And you get it to the point where it should be frozen, but it's not frozen yet. And if you take it and you can try this at home, Jocelyn, you can look it up on YouTube, and it's really cool. But you take it, and if you tap it on the top of a table, it suddenly completely goes into ice and turns solid. And it's so neat. And it's because basically you agitated it enough to get one of the ice molecules to align with another and form that crystal lattice. And once one does it, all of the others are like, oh, this is what we're supposed to be doing. We need to get organized. We're in liquid form and we're not organized. And they just start holding hands, and then they just go, which is really kind of cool.
I can make cooler water than that.
You can make what?
Water
Cooler than that?
Yeah, because I'm liquid nitrogen.
Oh, there you go. Have you guys been to the liquid nitrogen ice cream places yet?
Yes.
Those are
It's
so. Do you have any of those,
cool.
Jocelyn? Those are so
Like it's
fun.
liquid ice cream, and then they put it in.
Yeah.
And then they like ask you what flavor, and then they put that liquid ice cream in, like a bowl, and then
Mm-hmm.
they freeze it with like dry ice.
Liquid nitrogen.
Or
Yeah.
liquid nitrogen.
So they have a big liquid nitrogen tank.
And then it,
Yeah.
and then
really neat.
sometimes there's like tiny little dry ice balls.
Yeah, and
that,
they roll off.
fling
Yeah.
the table.
The liquid nitrogen.
Yeah, and
balls
they'll give you
roll
like
off the
these
table.
little things of cereal attached to a dowel rod.
Yeah.
And then,
Yes,
and then they spray them with dry ice, and when
It's
and
not
they-
dry ice,
no,
it's
dry-
liquid
dry-
nitrogen.
Yeah, I
Yeah.
keep saying that.
It's
And then when you eat it, if you breathe out your nose, it will
There's
go.
also it's like rolled ice cream, so they just
Oh, I love that.
and then they
That's
just
one of my
have it
favorites.
frozen, and then
Mhm.
roll it in like a cup.
Like the 8 degrees below. So if you don't have a liquid nitrogen place, or if you don't know, you should check that out, Jocelyn, because those are really cool. They take that liquid ice cream bit, and they shoot liquid nitrogen at it, and it just freezes before your eyes, and they stir it up and mix it with stuff, and it's fun. All right, so these are in your notes and your homework and whatnot. So let's have a look at these. So what amounts do you compare when you're measuring concentration? Who's got an answer? Anybody got an answer? Should be in your notes. What amounts do you compare when you measure concentration? What you did, Ella? She found it first. There you go. So it's this, yeah, the solute and the solvent, or the solute and the solution, depending on which way you want to do it. Oops, that last one showed up to you guys. Okay, how can you tell that a white powder is salt without tasting it? There's a couple different ways. What did anybody come up with?
If you put it inside.
What'd you get, Jocelyn? Hang on, wait, Jocelyn's gonna answer.
If you put it in water, salt will dissolve.
There you go.
And then leave crystals on the sides of the cups.
There you go.
I did that during a lab earlier in the year.
Very good. Yes.
One way to
I accidentally left the spoon in it and it rusted.
salt, but to rule out several other ways.
Yeah.
If you put it inside of a blender for a good amount of time, take it off, and then
Yeah.
it'll go.
What do you what do you mean by tasting? Is that what you're talking about? You can just know
Yeah.
it'll burn in your nose.
Yeah, so it
It's not a drug,
depends.
it's not a drug.
So one of the suggestions that the book had was you could measure its solubility to known levels. You could, sure. You'd have to know how much was in it though. I don't think that was the best question or the best answer, but I like some of the others. You could also see if it conducts electricity. If it does, then you know it's ionic. So that rules out a whole bunch of molecular compounds. So which solution will have more gas dissolved in it? A solution under high pressure or a solution under low pressure? Right. That's Henry's law. And then how does temperature affect the solubility of most solids? Drew, how does temperature affect the solubility of most solids? You know that one? Just think about it.
Well,
It should be on this page. Should be on this page.
Yeah, it's right here.
Yeah. So how does, it's number 4. How does temperature affect the solubility of most solids?
Of course, compare and contrast what happens when particles.
No, that's the wrong number 4. Yeah, what you get?
High temperature allows solvent molecules to more of, I think that's
Efficiently There
efficiently
you
break
go.
apart.
break apart the solute. Yep. Okay. So yes, the greater the temperature, the greater the solubility. Good job. All right. So then number 5, the dilute solution, that's going to be C, a solution that has only a little solute. Okay. Number 6, concentrated solution. Jules, you have your paper? You got it? There you go. Number 6, concentrated solution is a solution that has so much solute that it can, wait a minute, sorry, D, a solution that has a lot of solute. I looked away and lost my spot. Number 7, solubility. That is a measure of how much solute can dissolve in a solvent at a given temperature. And then saturated solution, a solution that has a lot of solute. Great definition. All right, so now you guys had the question, what is the difference between concentration and solubility, and how can each be changed? So what are some answers that you have? I want to hear some of your answers. Who's got one? Go ahead, Eleanor.
Solubility is typically a limit to how much solute can dissolve in a given amount of solvent.
Okay.
Concentration is the quantitative amount of solute dissolved at any concentration in a solvent.
Wow, where'd you find that answer?
Hmm?
Where'd you find that answer? That's a good
My
one.
dad helped me on that.
That's a good answer. No, that's a very thorough answer. I like that. So yeah, quantitative. I think there's an extra T in there. That's a tough one though.
I
It's a-
bet Cora would have better answers.
you bet who? Cora? Oh, Cora sometimes has really good
I
answers.
actually got my analogy from Cora.
Yeah, that was
Like, it
a great
just one
analogy.
simple question, and then they had this, but then they had like a whole essay afterwards.
Yep. Who else has theirs? I want to make sure everybody's got their homework. Who else has an answer for our homework question? Run 22. This one here. This is the homework question that I need to answer. What have you got? Lily, do you have one? Ella, you have an answer? Jocelyn, do you have an answer?
I don't have my paper up with me
Okay.
because when I woke up, I had breakfast and my mom went down to get her workout, and then I had no idea what time it was until I looked at my time, and it was
Laura and
9:55.
her out, man.
So I didn't bring my papers up because I was just rushing to get to class on time.
That's okay. All right. Anybody else have an answer they want to share? Let's see. Got one. Good deal. Okay. Well, we got lots of answers at least. We got some answers at least. So if you shared it, like you shared yours, it's good. I don't need to see it. If you didn't share it, either show it to me or toss it in the homework file so I know that you've done it. There you go. Oh, turn one more page. There you go.
I have it.
There you go. All right.
Make sure you make it.
All right. Oh, look at that. You made a frame. That's fancy. Oh, very nice. Good job. Good job. Good job. All right. Lil, do you have yours?
I already turned mine.
Oh, okay. Sure to put it up there. Excellent.
I got 5 bucks as an essay about this. This question.
I do like to look at Quora for answers.
That's all.
All right. So here's what we're going to do. All right. So wait a minute. Here's what, yeah, 22. So here's what we need to do. You can keep your homework in your binder. So Lil, just show me yours and clip it back in so you don't worry about losing it. Okay. And then we're going to go to lab, and I will do that demo today in lab. So I will record that and make sure that I post it for those of you who aren't here to see. So Sky, just send me your homework when you get a chance so I can see it.
Right?
Yeah, we're in 22. So, all right, Jocelyn, Sky, catch you later. See you again.
Bye.
Bye.